one is exciting. And for those of you who are tweeting tonight, please just use hashtag Hive data to keep the conversation going. These were just a few of the speakers that were on the Hive stage. The Hive think tank is a forum for thought leadership. Through our panel discussions, through our talks, we focus on two themes. We have more space here in the first row, so yeah, from the back, we can sit here. Thank you. So through our panel discussions and through our talks, we focus on two themes. One is all things data, and another one is entrepreneurship. Since our reception, we have organized over 170 events. Our community is growing. I see so many new faces today, so thank you to all of you who are with us here for the first time, and to all of you who are coming on a regular basis. We have already almost 9,000 members in our community, which consists of data scientists, corporate users, engineers, entrepreneurs, and on the stage we had almost 300 speakers. We organize the Hive think tank almost every week. Upcoming event is in the week of Thanksgiving, so if you're in town, we'd love to invite you to join us. Mohandas Pai will talk about India in the next 15 years and how it's going to become a 10 trillion economy through tech entrepreneurship. So please just join us and register on the meetup page as you did for tonight's event. All our events are posted on the Hive think tank and on our meetup page and on our website. So we have listed them only until December, but we are working hard and we have lined up some events until April next year as well. More about them on the Hive think tank. So without sponsors and without partners, many of our events wouldn't have happened. We'd like to give a big shout out to Baidu for hosting us tonight. If you're interested in corporate sponsorship, please just come and talk to us, Ravi, myself, and whoever is here from the Hive team tonight. All the Hive think tank events are brought to you by the Hive. What the Hive is, more from founder of the Hive and managing director, TM Ravi.
Thank you. What a great crowd. There are some seats here and there I see, so if you were standing, just look around. The Hive is a venture fund focused on early stage companies with a theme of AI and data and the value and disruption that AI and data are having in enterprise, IoT, and online. A broad set of themes around automation, around industrial IoT, around security. So if you are interested in the space, you're an entrepreneur, or want to join one of our companies, we'd love to kind of talk to you. And those are some of the companies that we have. So you'll see themes around IoT, like Foghorn and Sensify, around blockchain, around augmented reality, enterprise companies, and data center companies. So feel free to kind of reach out to me if you're interested in any one of them. One of our companies is here behind, and I saw Dan Turchin, the founder. So this is a company that uses NLP and AI approaches. I see a number of awesome employees here in the front that uses AI and NLP approaches to bring automation and customer service and customer support. And do, on your way out, kind of look for them and chat with them. If you are going to be on Twitter today, please use the hashtag HiveData. I am incredibly pleased to have this panel here today. We have worked with, so I'm pleased to have Jordan Nove from VentureBeat. Jordan, in my opinion, is the most knowledgeable journalist in machine learning that you are going to meet, and we're excited to have him here today. And in addition to Jordan, we have Dan Bickel, a friend from LinkedIn. He leads an NLP group there. Before that, he was at IBM Watson, I think. Richard Socher. Richard worked with Andrew Ng and Christopher Manning at Stanford. Did MetaMind. His PhD there was highly kind of acclaimed, and since he sold MetaMind to Salesforce, he's the chief scientist at Salesforce. We also have Carl Case. Carl Case is also a student of Andrew Ng, and so there's some common threads here. And is now at Baidu, and was before, I think, Carl, you were at Civ Science, if I'm not mistaken. So with that, maybe if I can get Jordan and the panel kind of to come on over.
Thank you so much, Ravi. I was told to talk directly into the mic. So if you ever see me slacking, just put a hand up or something. But anyway, I'm really happy to be here. I'm Jordan Obet. I write about AI, first and foremost, cloud infrastructure, Apple and Microsoft, and each day they intermingle, and it's interesting. And I get to write about, of course, LinkedIn, Baidu, and Salesforce, and before that, the company that Richard had. So we'll talk a little bit about that. But I'm really happy to be able to focus a little bit on the intersection of NLP and AI and deep learning, because it's easy for it to be mentioned among other things. And so we're going to try tonight to be more focused. So with that, why don't we have our great panelists coming out, Richard, Dan, and Carl. First off, maybe we can just go through our introductions, so I'm not get injured.
Be better for my posture.
Right. Okay, so you want to start, Richard?
Sure. I guess I was already just introduced. I'm Richard. Finished my PhD in 2014.
Put your mic right in front of your mouth.
All right. Yeah, then started MetaMind because I had a lot of folks reach out to me about whether I could work for them and apply some of these deep learning techniques and NLP to their business problems. And I felt like, well, if I just go in one company and I solve that one problem, I feel like the technology could actually be so much more broadly applicable, and ideally I'd write it once really well in some generalized platform, and then lots of people can use it. And that's why it was called MetaMind, sort of supposedly the hope was to eventually have lots of different sub-minds, but have one MetaMind, and that keeps getting smarter and smarter. And then we built a lot of technology. It was fun. We did some research. We had some customers. We worked with the largest teleradiology company in the United States, VRAD, saving lives with like having deep learning run in production there. Did some fun research on natural language processing. And then we're sort of at a stage where it was just about scaling sales and marketing more and less about the technology. And and the team and I basically felt like, well, what better place to partner with than Salesforce and their epic Salesforce, because they also, whenever they solve a problem, they just solve it for one of their customers. It wouldn't ever scale because they have over 150,000 different companies as their customers, and so it's like 150,000 different kinds of apps. And if you just build sort of an AI or any kind of classification algorithm to be more precise, it wouldn't scale to their kind of scale. And so it was a really exciting move, and I'm choosing to do so now.
Great. Okay, how about Dan?
All right. All right, good evening, everyone. First of all, I want to apologize. My name is Dan Bickel. I was on the website advertising this, but it was a black and white photo, and someone told me earlier that I appeared to them in color, which was not intentional, but please just deal with the discrepancy as best you can. So I run the natural language processing team at LinkedIn, and we do a lot of cool things and lots of deep learning. which is why I'm here. And before that, I was actually a senior research scientist at Google Research, where I worked both in NLP-ish problems as well as speech recognition. Anyone in the audience have an Android phone? All right, a couple of you. So yeah, all right, right on. I like both iOS and Android. I'm equal opportunity. But so if ever you've used what I guess is called Google Now, but if ever you've had that thing where you want to say something and have something done on your behalf, like send an email to so-and-so with the message, I'm running late and the subject late, or tell me how tall Barack Obama is. So that's our semantic parser that I built with a couple other guys at Google. So that was another fun project I did. And yeah, amongst others. So at LinkedIn, there's lots of text, which is a lot of fun to deal with because we have tons of text in multiple languages and structured information often connected to it. So it makes the problems even more interesting, even more fascinating. The text itself is interesting. We have obviously many genres of it. One genre that's of particular interest is profile text. So your profile is like, right, your modern version of a resume. People write differently. First of all, they try to write cleanly, and they tend to omit subjects. In linguistics, you call this a pro-drop language, right? You don't need to say that it's you that did this stuff because it's obviously about you. So the language is different, and we are trying to essentially find semantic representations so we can solve a lot of the problems that are of interest now and in the future for LinkedIn. For example, if we can find good representations of profile text, of job listings, we can perhaps find good ways of saying, yes, this would be a great job for this person. Or similarly, for people, we might be able to do a better job at suggesting, hey, these are people that you might want to know. So there are lots of problems like that, and then some. And we work on all of them.
Okay, great. How about Carl?
Cool. Thanks, Jordan. I'm Carl. I've been here at Baidu a couple of years. So before that, I cut my teeth in startup land, working at a company that was doing machine learning for anti-fraud fraud detection. So in my time here, I'm now a research scientist in Baidu's Silicon Valley AI lab. Done a lot of work on speech recognition, and then more recently have been running a small team focused on natural language processing, especially for language understanding applications like the ones that Dan was talking about, because as you might imagine, if you have a speech recognition system that you want to get in the hands of users, you might want some other technology to go along with it. Yeah, I think the mission of Baidu's AI lab is to work on hard AI technologies that let us impact hundreds of millions of users, which is, a big statement. I think it's good to have big statements, but it does mean something concrete, right? Which is that I think there's really valuable and useful AI research to be done, where there's not a clear sort of short, medium-term path to having a big impact on a large number of users. And that's really great and worthwhile work, but that's not our focus. There are also really great ways to have impact in technology that have nothing to do with AI. I know that's heretical in 2016, but I think there's plenty of work to be done, not in deep learning, which is great work, but that's also not what we're about. We want to sit at the intersection of those two things. One of the other things that I think is pretty exciting about being at Baidu is, this may come as a shock to some people, but it's a Chinese company headquartered in Beijing. And so a lot of the problems we've worked on in places where, my background, you would only work in English, you actually even start by assuming that you're going to be working at least in English and Chinese, if not more languages than that. And so our speech recognizer, for example, the deep speech system, is essentially the same system, and it works both in English and Chinese. And actually, one of the guys on my team who led the development of the Chinese system does not speak or read Mandarin, and was still able to build I'd say it's probably the best Chinese speech recognition system in the world. That might be controversial, but I think it's true. And so, this may or may not come up, but I think this is one of the exciting promises of deep learning, and I think whether it's going to be true in NLP as well is an open question, but being able to attack problems without the same deep domain knowledge, instead using powerful general purpose techniques is an exciting opportunity.
great. I always love introduction, especially when there's someone from LinkedIn. Like, you can just read someone's LinkedIn and see what they're about, but it's always interesting to see a LinkedIn employee sort of expound upon their face.
There are always things you can learn not from the profile.
Can you provide some insight? Any
Yeah,
suggestions?
like things that don't appear on your profile. You mean suggestions of things that don't appear on my profile?
Like, after you connect with someone and then you get their email address and you can just sort of go about asking questions that way to learn?
Sure. I mean, that's one way. Or you can be, in a very private setting like this one, where it's just the two of us, and you learn new information. But I mean, there's always that little extra layer of, there's your professional persona, and then there are the few personal things that probably don't belong in your professional persona, but that's, yeah. So we have actually a tradition at LinkedIn that for every batch of new hires, 3 are randomly selected to talk about themselves, introduce themselves, say one thing that's not on your profile, and then exhibit some special talent.
That's great.
So yeah, I'm not going to do that here, but I will happily attempt to do so if I see you after this.
The problem is that this is going on YouTube afterwards, so it'll all end up online anyway.
Fantastic.
So anyway, just total tangent, apologize. I just wanted to actually...
There goes the focus.
Yeah, first question. But anyway, I wanted to actually start out by talking about the current problem sets you're thinking about right now, the current approaches that you're using right now, the current applications that you're trying to build right now, beyond the sort of historical view that we've all provided so far. So for example, Richard, you have this Salesforce research thing. What are you sort of working on?
That's you could probably talk an hour to give the answer to those 3 questions. Let me try to split it into 2 things. So I'm the chief scientist. I care a lot about research and actually publishing papers and pushing the state of the art in artificial intelligence forward. But then I, of course, don't do that in a vacuum. I also want to see some of those things that we do, not all of them, but a subset of the things that we do in the research group to also impact all of our customers. And so let's start with maybe the research, because in my view, a lot of ideas sort of germinate and start in research, and then they incubate in research groups for a while, and then they sort of graduate out of those kinds of groups into engineering groups and product groups, and then they have impact on normal people. And so on the research side, I am very excited about multitask learning. I think as a field, especially thanks to deep learning, we can take any kind of data set now, as long as it's reasonably large, and we can train neural network models, or deep learning models, which is often quite similar, but the standard sort of definition of a neural network doesn't encompass all the various bells and whistles that we now put onto these models, like attention mechanisms and various modifications like that, and memory architectures and so on. So that's why I'll say deep learning for most of the rest of the talk or panel. But basically, we're very good at taking a single task and optimizing it and getting really high performance. And so as a researcher, I feel like we've done that. Now what's the next level? And I think the next level is to not start every project that we do at some random point, random weights, and retrain our model for that new task. But ideally, we'll actually continue to train a single model that just gets smarter and smarter over time. And only if we do that will we actually ever get to a truly intelligent, even just natural language processing system. And of course, after that, maybe we'll have to combine other modalities, visual modalities, databases, and so on into that single system. Now, that's an interesting research problem because it's not solved yet. Next week, we'll publish a first paper on this, where we'll take a first stab at that problem and have a single model that solves 6 different NLP tasks. But there are hundreds of different NLP tasks, and ideally we would solve all of them. So I want to give the other speakers some more time, but there are a couple of other fundamental problems that we have in NLP systems and deep learning, and really generally machine learning. One is we can't predict words that we've never seen at training time. Right? When you try to train a language model or a machine translation model, it will only ever predict things because in the end there's like just a standard classifier in most cases and the decoder. Now, another paper we're just publishing next week, actually it's now already on archive/ICLR, so one of the great conferences of the field, the International Conference of learning representations. We actually incorporate into these deep models a pointer, so you can point to words in your test set and actually predict words at test time that you've never seen at training time. And that's like a fundamental issue that I think this kind of work tackles. And then there are a couple of, you can get even more technical. I don't know the sort of preference of the audience, but I think the most technical thing is that a lot of people who here knows word vectors, like word to vector. All right, awesome. All right, so word vectors are great, right? Everybody loves word vectors, and embedding all the things all the time. With sometimes some ideas to how we embed word vectors. Now the problem is when we have an encoder, we'll have word vectors, and when we have a decoder, we have again a classifier, and often a classifier for every single word. Now that's suboptimal because then really what that means is you have two types of word representations, one for an encoder and one for a decoder. And so with a project that I've done with two of my students from the Stanford class, we actually tied those two word vectors together. So you have a single word vector representation for both inputs and outputs. And it's again one of those fundamental issues where like, this doesn't really make sense. This is like a lot of parameters, usually 100 times 100,000 different ways that you want to learn, and you're not sharing statistical strength between the inputs and outputs. So anyway, I could go on for a while. Next week we're going to have 5 papers. I'm super excited right now. The deadline is also tomorrow, so I'm going to run back to the office right after this. Now, on putting the research aside on the applications, there's so many things, and in some ways we have to start at just the simple stuff, like image classification, document classification. And just those two things can already be super duper impactful, so you want to make sure they scale well, they're very robust. And sometimes there's actually a back and forth between research and some of those applications. You would think image classification, that's pretty much done, but there are actually a lot of subtleties when you want anybody to be able to train their own image classifier. So let's take, for instance, we can all train on a balanced data set and separate out cars versus Matthews. That's super easy, and you have 1,000 examples for each class, and it's like, okay, that's done. But now you might have customers that come and say, well, here's my company logo. Here are 50 examples of my company logo. Now go and find them in the 1,000,000 or 1 billion Twitter images for the next couple of weeks. Now, all of a sudden, you don't have a nicely balanced labeled data set anymore, and you still want to solve that problem. And that actually then becomes kind of an interesting research problem. How do you deal with super skewed data sets and things like that? So sometimes you can go back to things you thought were solved from the research side and actually, in real life, see that there's still work that needs to be done. So image classification, we're continuing the medical work that we had started at MetaMind, and then also apply it to Twitter and marketing. And then on the text side, of course, text is even more important than images, at least for Salesforce, and there's just so many things that you can do if you have a very solid, even just classification engine. So, so Salesforce, for instance, runs a lot of customer support centers. And so whenever most of us are customers of some company that likely uses Salesforce. And so they're kind of one step removed from normal customers, because they're often their customers' actual companies. So there's one recursive step there. But in customer support centers, as an email, for instance, comes in, we might want to automatically assign who would be the best person to answer that, or in some cases, they're super simple, like, oh, how do I respond to this email? How do I recover my password or something like that? Whether you see it many, many times, you might just want to automatically send an answer to some of those kinds of emails. So there are a lot of interesting applications in the service, sales, and marketing worlds. And some others.
Great. I love the deep answer. Sorry. Dan's been dying to jump in, so let's hear from Dan.
Okay, so yeah, let me tell you, I guess first I'll mention some of the application areas, and then why they're, and some of the research that goes into them on our side. So like Richard, we also have sort of more applied things that we're trying to worry about, and more fundamental theoretical things we're trying to work on. So on the applied side, a lot of the problems that we're working on that are natural language processing problems are traditional problems, and I'll mention a couple of them, but they have an interesting slant or twist to them because of the data that we have. So one set of problems will go by the name multilingual information extraction. So this is like an umbrella term for what has historically been a suite of processing steps that you might make on text. Useful analyses. It will be all the way from the low level tokenization or segmentation, perhaps lemmatization, part-of-speech tagging, syntactic parsing, named entity recognition or entity mention detection, coreference resolution, and then there's a step on top of this. This is the suite of problems that we're working on. There's a problem that's on top of this that's often known as entity resolution or entity linking. And so this is where we have the application meet some of the interesting theoretical problems that we're tackling. So at LinkedIn, like at a lot of places, we have interesting sets of entities. Historically, in natural language processing, there were three kind of very, very broad classes of entities, to use this word. There were organizations, persons, and locations. And so a lot of work for ages, meaning like decades, has gone on with these three types. And then in more recent years, people have been focusing on subtypes of these three. And sure enough, yes, those are interesting types of entities, and we've got lots of them. In fact, at LinkedIn, we have members who are either people or organizations, and they're connected to other things that are of interest. Like if you've ever been on LinkedIn, you might notice there's some prominence to things like your skills or job titles that you have. So these are other taxonomies that we curate in both automated and manual ways, and we try and find good representations, not only of these entities. So this is along what Richard was saying, embed everything, right? Find a useful embedding for anything. And I'll mention what useful means. But it's also the relationships between entities that are important, right? So we already have some relationships, a lot in fact. So on the platform, we'll have relationships between, say, a LinkedIn member and that member's job history, the institutions or organizations for which that member may have worked, and the other members, the other connections in the graph, right? So LinkedIn calls this the economic graph. So discovering those connections that don't yet exist, or perhaps that exist only because they're asserted in text, that's a grand research problem for us. So there's the state of the world that LinkedIn knows about. It's the economic state of the world, this economic graph, right? These are all the members and their connections, and they're connected to jobs and institutions. But then there are new things happening all the time. These new things often get asserted in text, in blog posts and little short text updates and newswire articles. And so a big focus and challenge for us is, can we discover events that are asserted in text that we can then merge and make meaningful new additions to LinkedIn's understanding of the global economy and the global workforce. So that's like a really big deal for us, because I mean, when people can find jobs, when people get new education that leads them to more fulfilling professional lives, then we win. And LinkedIn's not a charity. LinkedIn makes money doing this, but it's kind of one of those, that's part of the core mission. So we're trying to discover, and this is a problem that is near and dear to me, which is event understanding. And events are this very, very broad class of things, if you let them be. But for us, we have finally I shouldn't say finally, we have a narrow enough scope to make the problem both tractable, but still hard and interesting. So it's economic events, right? Economic events that involve people and organizations. Even simple things, right? Someone getting a job is a simple type of event. It often gets asserted in text. We'd like to know when that happens. And then that can suggest how we might augment our graph and our understanding of the economic nature of the world. So that's a big area for us. And another big area is machine translation. LinkedIn is localized to 25 languages. We have a priority list of which languages we care about. We care about all of them, but we can't attack them exactly all at the same time. But we can do them in phases. So we're working in multiple languages. We have to worry about machine translation, and we're working on conversational interfaces. And I will leave it at that for now.
Carl.
Shall I go? All right. Trying to think if I'm gonna keep this short and compact. So, I mean, Baidu is a search company, right? And so Baidu cares about many things, but one of the things Baidu cares about is language interfaces to technology, right? What is a search box but a natural language interface to the internet? And one of the great promises of NLP broadly, and I think improvements in NLP that are coming from learning, especially better word embeddings, things like that, is finding other ways to put natural language interfaces in computing devices or anything that sort of is a computer, which in the limit seems to be most things in the world. And so a product example of this actually is this. Most people here probably wouldn't have seen this, but Baidu actually very recently launched a product in China called Melody, who is a nurse QA thing that I probably won't do a great job of describing. It's all in Chinese, so I've only watched other people use it. But the idea is if you have medical concerns, like right now what do? You go and you type stuff into your favorite local search engine, and then you develop great anxiety about all of the terrible things that you probably have, which is not the best user experience, I would say. And so Baidu for a while has actually had a product that allowed you to chat with a licensed doctor, where you could say, like, I am having such and such problem, and then they can ask you, well, is it A or B, or how extreme is Y or Z? And this would allow you to get slightly more valuable and less terrifying information than random searches on the internet. But that's very high latency, right? Doctors also are not doing this full time. They have clients, they work jobs, and so people couldn't get information as quickly as they wanted to. And so one of the teams in Beijing has launched a product where you interact with an AI agent who simply is asking you questions, right? It's not providing medical advice. We don't think that AI is there, but it is able to work through sort of a structured and slightly unstructured set of questions in order to understand, like, what is the information that I need to get from you in order to ship that all off to a doctor who can then go through all of that, pick out just a couple of things that he or she's missing, and then get you some kind of diagnosis or recommendation much faster. And so it's a pretty cool product. And so you can imagine there's lots of places where people are interacting with this in a fairly structured way, but also want to be able to just type free text about what they're saying. And so you want to be able to pull out entities, for example, as Dan was saying, that are keywords or organs or whatever it is, symptoms, and be able to match them to some kind of more structured knowledge base. And so I think this informs maybe two lines of research that I can talk about briefly. One is, and this is related to something that Richard mentioned, which is this idea of, well, from my point of view, it's about how do we build good machine learning systems for text when you don't have a lot of data in the domain you care about. And so I think multitask learning is a very promising avenue of attack here, right? That it's actually not that hard to get lots of text, but it can be very hard to get lots of text of the form structured conversation that you had over a chat agent with a doctor. And so we don't want to, and a lot of the success in deep learning has come from, here are 1 million dogs and 1 million cats, and given that in 10 days of training, you can learn to discriminate dogs from cats very effectively. But if you can't get 10 million examples of conversations with doctors in any reasonable amount of time, how can we adapt models that have been trained on much larger but out-of-domain data sets into in-domain data sets? And one particular problem we care about in this area is semantic parsing. And so I think actually I'll leave it there because this may come up, and if not, grab me after. But this is a domain where it's very, very hard to build large data sets. And I feel pretty confident if you gave me 100 million paired examples, you could build a really, really good semantic parser, but no one has 100 million paired examples lying around.
So I just want to add, Andrew Ng actually came up to VentureBeat's office a few weeks ago to show me this product. And I wrote an article about it, and he said there were lots of conversations that already were online that Baidu had to take from. And so I guess it maybe makes sense that it's not available in any language other than Chinese. But what conversations were they that Baidu chose to use as training set?
So my understanding, which is imperfect, is that Baidu had this pre-existing product that allowed users to interact with doctors directly. And so having launched that previously, we were able to collect these examples.
No other additional conversations that were online in Chinese about, oh, my elbow hurts, my leg hurts, my knee, nothing like that.
I know they were able to use lots of structured information. Baidu has a pretty good product actually for getting structured medical information, like disease, diagnosis, symptoms, things like that. And so we pulled a lot of that structured information, but I should say I did not build this product. So
That might be a good piece of advice for anybody here who wants to use artificial intelligence algorithms for anything, is start collecting your data. And try to do it in some structured form where you say, if this was the input, then this is the output. The output could be, these are the sequences of actions you're doing. The output could be, this is the answer email. And so ideally, you have some system of records, CRM, that keeps track of what you're doing and what your folks are doing, your employees. And so as you do that, then only then can you start making use of deep learning, of NLP algorithms.
That actually just reminds me, today I got to publish an article about the Google Home, the smart speaker. So I had one in my house for about 5 days, and my girlfriend and I were talking to it all the time. And I found another article in Ars Technica today that talked about how Google has been enhancing its speech recognition repositories since 2007, when it launched 1-800-GOOG-411. Do you guys remember that phone number? Okay, so you could call it and just ask things and say things, and it would give you information back. And now we're, 9 years later, and we have this smart speaker. And that data set, although it might have been a little bit more raw based on how people were used to talking to Google, or Baidu for that matter, these very bare bits is now being tapped to provide what many people who got a chance to review it, including me, would be very impressed by the accuracy at which it was able to understand what I was saying.
Yeah, fake it until you make it. But a lot of times, and when you try to train a system, you first have to collect the data, and so it often makes sense to launch the first version without any AI, where you just have humans or maybe the crowd sit behind, the chatbot interface or the live agent interface or something like that, and answer. And then after doing that for a couple of weeks, you can then extract data and then have your system start to get smarter and then take over pieces of that.
Yeah, this is a very common paradigm, that you want to launch something that you may have had to have built by hand, but it allows you to collect data. And it might be something that is also, it might have been trained for some other task. So in the case of that Goog 411, that was an automated system. So it was bootstrapping off of an existing system that was far, far below what we now consider the state of the art. But that's okay. It did well enough. Users kind of liked it. They used it. It was a novelty at first, but you can collect data this way. You deploy something that's usable enough, you can collect data, and then you can iterate. And that's pretty powerful.
I do think, though, it's gotten a lot easier in the last 9 years to construct large-scale data sets without having to be a company at the scale of Google and to go launch a product and then do lots of PR. I think, everyone has smartphones to a first order. Amazon Mechanical Turk has had a surprisingly big impact, I think, on the machine learning community, one that's often underestimated, and just the ubiquity of data on the internet and the ease with which you can get lots of people to crowdsource data sets has made it just so much easier.
Actually, I wanted to bring up a sort of random question. When people talk about, say, convolutional neural nets, they usually, my understanding is that you're working with labeled data, generally with supervised learning. So I was wondering,
There are some convolutional autoencoders, but you're right, the most commonly used one, but not sort of the definition of convolution is just a very simple mathematical operation. You can have unsupervised objective functions on top of those kinds of networks.
okay, so in the case of label, that don't do that. Who labels the data? Do you usually use something like Mechanical Turk? do you use, I think you mentioned Crowdflower. Do you ever get a chance to get your hands dirty with the data and start labeling manually?
I did back in the day.
Tell me about it. I'm curious.
I mean, you just sit there and you keep labeling stuff. It's not that exciting. But it's a very important, necessary first step. And then just like labeling the data is one step, but then you might have 3 people label the data 3 different ways. So then you might want to have some majority vote over that decision. There's a lot of complexity in how to collect good label training data.
So this is the secret sauce to a lot of machine learning, is to get good label data. And for natural language processing, historically there has been a lot of effort and expense to get good label data. I helped oversee a lot of annotation before Google. I was at IBM Research there and at Google, and now at LinkedIn. Long ago, I learned the hard way that I would never ask someone to label something until I tried doing it myself. And yeah, there's at least one person nodding in the audience. So there's a reason for this. It might be obvious, but you will more than likely end up with a pile of noisy garbage if you don't investigate the data a little bit yourself. If you're really expecting especially a complex output, you might want to think both hard about what that output should look like and then actually dive into the data yourself. So this is something I still try to do wherever possible. And yeah, it's good that there are people in the world who are very good at labeling data, and there are people who are good at modeling data, and those are often disjoint sets of people. And I can't do data labeling for too long before going crazy. So yeah, so I'm one of the more modeling people.
So one of the interesting side notes here is that the most ideal case, the standard process that was done manually by people can be used to actually extract data from the past. So for instance, we have a large customer support service organization, and people have already been emailing and giving answers to emails, and you've kept track of them, and this was the input, and in the end, this email associated with this knowledge base article, for instance, was the final answer. Then you can use that kind of data to bootstrap the whole thing. You don't need to actually sit down and label. But then there are a lot of other machine learning kinds of tasks where you just don't have the training data yet, and then you have to do all that.
It's always nice when you get data for free like that. Like machine translation, it evolved as a field because of government mandate. So the Canadian government mandated that all official documents appear in both English and French. That was the first main training data set for machine translation, were the Hansards.
Bible.
Yes, but the Hansards.
The first one.
Yeah. It's one of the things that kicked off the IBM models 1 through 5. And so that was a very big deal. And now we have EuroParl, right? So you have data in multiple languages. And so this is data that you get, it's not really for free, but some entity decreed that data must appear, in multiple languages. And we have strong belief that the meaning of those texts should be the same. So at least that's a great starting point. But yeah, it might come from email that's connected to documents. It might come from search query logs. You can get data for free in a lot of places, and it's always a beautiful thing when it happens. But often in NLP, we're not so lucky.
The moral of the story is you should get the taxpayer to pay for your data.
Wait, did we just wade into politics? This is dangerous.
The only other comment I was going to make is I want to actually agree with Dan that I think labeling your own data is often actually just the first step of being approaching a new machine learning problem as a machine learning practitioner. Going and trying to label some data is very often the most productive first step. And I found this to be especially true in NLP, where I think I have less experience than everyone else up here, is that often your output domain of the thing that you're trying to build is it's not obvious what you should be trying to map into, right? In image classification, it's kind of obvious that the goal is, okay, what is the primary object in this image? Although even there, the question of what does it mean for something to be the primary object is tough. But if I'm trying to, I'm building something like Google Home, right? And the user says, I want pizza. I need to have some kind of model of what are the set of things, like can users, what does it mean to want something? What is the set of things that users can want? What am I going to do if users want things? Like there, what you probably want is something that's mapping into like, this is a food request for delivery with type pizza.
It's an implicature is the technical term for this. Like you don't really, well, you may in that case want pizza, but what you really want is, please give me a set of restaurants that I can perhaps order for delivery or something.
Exactly, and so you
So
have,
that you can get them.
right, so you have to be careful to construct your output domain correctly such that if you're then going to have people label data for you, they can come up with a label for that instance. And so often you find like, of the 100 examples you think of at first, half of them you don't even have a way to label. And so it's time to get back to domain modeling.
So I just wanted to wade a little bit more deeply into labeling because I find it very fascinating that you guys are revolted by it.
Wait, did we say revolted?
That's a strong word.
It's a strong word, but I'm a journalist, so So anyway, I was wondering, in terms of what irked you so much about it, what made you decide that you're better at modeling the data, like you said. Was it that your eyes got tired of staring at blocks of text, or what is it that bothers you so?
I mean, I can take that jump on that
I
grenade
don't know
for
what you
you.
mean.
I got repetitive strain injury from labeling vessels and angiograms as an intern many years ago because I had to label a lot of vessels, and it took a long time. And it's really just not that fun. I'm not revolted by it. It's just like boring to keep labeling, looking at X-rays and labeling like the vessel boundaries so that you can then use that data to train your algorithm. But in many cases, it's the right thing to do. So you can try to build an unsupervised, in this case, vessel segmentation algorithm many years ago, or same with NLP systems, and you just hope that whatever unsupervised objective function you had, it comes out with the right thing that you wanted, which is very, very rare. Even a simple thing like clustering, where you might just want to find groups of, let's say, customers that you might have. Well, do you want to just find very large groups, like their male and female customers or something like that? Or do you want to go much more specific and say like, certain people in this zip code who like to buy this product or something like that? And a completely unsupervised clustering algorithm would know which granularity you would want. So in many cases, you have to give it some input. And I have sometimes folks approach me and say, I want to really do it unsupervised. And I say, well, you can just spend 1 week and maybe $5,000, and you get thousands of training examples for that particular case. And then you can just make it a very standard supervised classification problem. Or you can spend the next couple of months trying to do a research project with an unclear ending and try to do it unsupervised. And just in many cases, the answer is quite obvious.
Yeah, a little data goes a long way. So unsupervised learning is really cool, and it's actually a great way to write papers. But supervised learning and semi-supervised learning, you can do a lot if you were to spend that $5,000 and get a little bit of data, and maybe like, well, I guess we were all talking about this, where you've got lots of unlabeled data, and maybe you can learn something from that as a starting point, a good prior, and then train on what labeled data you have. But yeah, that will almost always do much, much better than some completely unsupervised method that you might try.
And that's true for both industry, but also for academia, right? There's certain data sets that have really pushed large communities forward as the next step. You might say deep learning wouldn't have been where it is today if it hadn't been for ImageNet, Felix group, or now, for instance, question answering is a task I'm very excited about too. It is a very cool data set. It has 100,000 questions and answer pairs from Stanford to Stanford question answering data set as quad. It's a really interesting data set, and only because you now have this large training data set can we use neural network models to actually really do good question answering. So it's a pretty fundamental connection between the data and algorithms.
I actually am tempted to ask you about why larger companies don't do more of this. Like, I think there was a recent release from Google about images with links to, or the URLs and the descriptions for the images. That's from Google research in the past 2-3 weeks. Why didn't Google release the images themselves? It was the URLs to the images.
It's just a legal problem. They don't technically own the images, so they are now redistributing them. Some you might make money of the ads of those images. It's just a legal problem.
So why with
Same
Google
with
research?
tweets.
Okay.
most people just release the links to tweets instead of the tweets themselves because of legal reasons.
So we have Salesforce Research, this new research organization. Obviously, Baidu has research, and LinkedIn has some semblance of researchers. I'm not sure if there's a formal research organization, but how come there aren't more widely recognized research releases of data rather than algorithms?
So we just announced our existence as Salesforce Research at Dreamforce like 4 weeks ago. So that's one reason. In those 4 weeks, we published our first data set. It's based on Wikipedia, so there's no legal issue. And but it's the right kind of pre-processing, and I think it's also useful for that subfield, which is language modeling. So we're not, in general, we're very open to publishing both the papers and eventually also the data. Of course, I think every company will know this. In many cases, you also don't have the rights to publishing the data. Most companies will go bankrupt if Google was to publish everybody's Gmail data, which is, I'm sure, a great data set for pushing their advertising algorithms incredibly well. Very few people would use Gmail. And likewise, Salesforce, as trust is our #1 value, we would never publish anybody's data without their consent and so on, and most people don't want to give that consent. So, and that is true, I think, for sure, for LinkedIn too.
Our users own their data. They're the real owners, and we respect their privacy. So we're not about to, unless the user wants to make his or her data public, it's not for a company to decide.
And then even if they decided to make it public, it would be tricky for them to release it and somebody else downloads it, and then maybe they later want to change it, and they're now embarrassed by that internship they've done 20 years ago or something, and they really want that to be gone from the internet, and now the data set's out there. It's tricky.
So privacy and security are two very big reasons that you don't see more. I mean, there are plenty of data sets, but you have to be careful. Like public resources like Wikipedia, yeah, you can go to town. But a lot of data out there is created by people, and there are user agreements between those people and the companies that they're interoperating with. So, yeah.
And there are examples of companies who have published anonymized data, and then security researchers went to town and de-anonymized the data, and it's a huge issue. So,
sorry, I think that happened with Netflix a few years ago. But I actually want to go back to you, Dan. I want to find out what it is that you don't like about text and labeling it. Why is that so hard?
Yeah. Okay, first of all, the premise of your question was a little bit suspect. So I think you said something like, what is it about text that I don't like? Yeah, I love text. There's
labeling
nothing.
it, I mean.
Yeah, so labeling it. So part of it is that for some tasks, it can be very repetitive, and you do need to find the interesting bits about labeling, but it can be, it's very challenging when you're doing such repetitive actions in some cases. And so, plus, one of the things you can measure is, we often call it inter-annotator agreement. There are various metrics that we use to figure out if people are doing consistent things. But we also often measure intra-annotator agreement. So that's trying to measure how often is a person consistent with him or herself. And this means that if you annotated the same data 2 days later, you might mess up. Or worse yet, if you're on some task and you're doing it for 4 hours straight, by the 4th hour, you might be fried and producing data of much lower quality than at the first hour. So it can be an exhausting task. And yeah, I think there are a lot of engineers here, right? And engineers are fundamentally lazy. We want to do efficient things. So that's kind of why we build stuff that tries to automatically do stuff, right? So that's why the manual effort to create data it's essential. It's an essential part of machine learning. Whether that manual effort comes from the crowd, it comes sort of naturally, or is mandated by government, but it's hard. And part of what we try to do is build abstractions, so that we can step back and build a model.
He touches on an interesting point, which is the ambiguity. I have a fun side story. So as I was collecting the Stanford Sentiment Tree Bank, we got also a lot of annotations, and there's some examples, and you only realize that when you really try to push the state of the art, and then you look at the errors, and there's some cases where your model is really wrong. Like, I wonder why, and you start looking at it. And one of the examples where even the training data had some issues was the sentence, "This is a great movie for frat boys." And now this is a very positive movie review for all the frat boys, but it's a very negative review for all the New York intellectuals and non-frat boys out there. And so there's some just fascinating ambiguity, and it often comes out as people label their data, especially in text.
Okay, this gets into something that's related but different. We were talking on the phone to prepare this call about one challenge that, or one trend, I guess, that has happened, where people who do what you do are seeing their jobs change to a degree. In terms of feature development, feature engineering, the way in which you come up with the characteristics that you want to do things with. And I'd be happy if you want to adjust the way I'm describing these things. But anyway, what is happening? What are you seeing in terms of the old way of doing things with older traditional random forest or SVMs, machine learning approaches? How is it different now in terms of developing or looking for a particular feature in the data that is already now labeled?
Sure, I'll start. Well, I think maybe it's sort of helpful, I think, to just give context for some people in the audience. So if I use the phrase feature engineering, how many people feel like they know what I'm talking about? That's a pretty sizable fraction. So if you think about actually any machine learning model, including a deep learning model, right? There is some set of inputs and some set of outputs. And in an ideal world, the inputs would be the exact bits that I have for the data. So if I'm working on a speech recognition task, it's the exact bits of whatever the WAV file I have is. If it's a text understanding task, it's just literally the string of characters in that text. But often, especially historically, it's been very, very challenging to think up models that can take just these bits as input and then map them all the ways that they that we care about. And so a large part, and I'd say probably in practical machine learning systems, which you guys reach the majority of the sort of quality of the system, setting aside getting a good training set, comes from the ability to think of transformations to those input bits that make it easier for the box that you're building that in between that's going to map from the input to the output to do its job. And so in speech, for example, people have thought up all sorts of signal processing tricks that allow you to extract interesting phonetic or prosodic structure from the speech signal that'll make it easier to figure out what character is there. Or in text, people will use things like, I don't know, part of speech tags. What are good features in speech text? Bag of words?
No, you might use, if you are doing part of speech tagging, you might want to use, for a language like English, it has very little morphology, but it has some. So morphology, just like things like word endings or prefixes and suffixes. So you can use, here's a feature of a word. What are the last 3 characters? What are the last 2 characters and what's the last character? If the last character is S, that might be indicative that this word is plural. It might also be indicative that it is a verb, like he goes, right? So you use features like that. These are features of the input that might tell you something about, something salient about it that you can then make the right prediction. Like, oh, yes, this is a present tense verb.
And of course, the beautiful thing is with deep learning, we don't have to do most of those things anymore because we can give it more and more raw data. It's a great paper by Joe, Professor Joe, and some of his students on machine translation, where he literally takes several different languages. He has an encoder that just goes over all the characters of mostly sort of Latin vocabulary type languages, and then just has a decoder that goes to other characters in those other languages. And it's a single model that can translate between multiple different languages. It's all jointly learned, and it's only based on characters. It's pretty incredible. And this kind of character, like going down to a character level, you need a lot of training data for. So machine translation is great because they really have large training data sets. it would be harder to do that for semantic parsing with some rare diseases or something like that.
Well, this is sort of the great promise of deep learning, I would say, maybe more than anything else. There's this phenomenon that I call machine learning hubris, which is we like to think that since we have powerful general purpose techniques, we don't actually have to understand the domains that we work in, which is not actually true. It has never been true, and I don't think even is true now. But to get to your question, Jordan, I think it is possible now to work productively on machine learning problems and spend significantly less time learning about the specific structure of the domain, of the data from the domain that you're working in. So as an example, when I joined Baidu, I worked for a while on our speech recognition system, and I had very little background in speech. And if you read traditional speech recognition papers, there's a lot about linguistics and phonetics and the structure of language, both in terms of the acoustics and how it's spoken, and also the linguistics and how the words all fit together. And I think it's interesting stuff, and I've gotten to pick up a lot of it along the way, but I'd say almost none of it has been useful for improving the quality of our speech recognizer. The biggest quality improvements have come from improvements in our training data and improvements in both the architecture of the deep neural net we're using and ways to optimize it. Now, this is different, I'd say, from not understanding the data, and there's like one distinction I want to make, which is how do you make machine learning systems better? Mostly you look at it's getting wrong and then go think up ways to fix the things that it's getting wrong. And so what deep learning has done is give kind of a new axis along which you can think of ideas, like think up ways to change your optimizer, think up ways to change your architecture, think up transformations you can do to your data that are kind of domain agnostic. But still the actual process is kind of the same, which is build a thing, you look at the errors, think about what you can do to fix the errors, try it out and see if it gets better.
Or collect more training data.
If you have no fitting problem.
But the nice thing is that you also don't necessarily need to abandon all the work that you might have done on feature engineering in the past. To use the terminology, you can feed to your input layer of your deep learning network. You can feed things like characters or bytes or bits, and basically raw versions of your data. You can also feed features that you've computed that might be arbitrarily complex to compute. And in fact, you could try to start from such features and see what happens when you allow a deep learning framework, especially one that has, say, more than one hidden layer, right? Part of the promise, anyway, is that it's learning interactions between your features in a way you're getting that automatically. Whereas the old way of doing things, you'd have to manually encode such interactions, like, yes, this word ends in S and starts with PRE. Right? That's like two different features, and I'm sort of manually could construct a function that says, yes, both are present. But with the promise of deep learning anyway, and it seems to be borne out in practice, is that it's learning these interactions automatically. And there are good technical reasons for why this is so, but it's effectively exploring the space of all possible interactions.
I want to open up one question that came from a response to a tweet that I sent out earlier today about this panel. Someone wanted to know, and actually I wanted to know this too, so I'm really excited about listening to the answers. Someone wanted to know about what speedups you have seen when deep learning is applied to an NLP problem, and specifics would be nice to hear about.
Speedups along what axis?
Yeah.
Well, if you have a traditional NLP system with an older school machine learning approach, you get a certain type of result. For example, with machine translation, let's just choose one context. There are certain predictions that it makes, and then you know what? This one's wrong. Users show that what you have is wrong, and then you introduce, just as a test to 2% of users, a machine translation system powered by, an LSTM RNN of your choice, and you might see some